All right, in this video we're going to talk about the properties of logarithms. It's the second video that I'm doing in a series of videos about logarithms. So if you haven't seen the first one, which is just about the definition of a logarithm and how it's related to exponential functions, you should probably check that one out before you watch this one, because I'm going to use a lot of the things we talked about in that video to kind of talk about these things here, these properties of logarithms. All right, so we have four properties of logarithms. And they're kind of related to the laws of exponents a little bit, or maybe a better way of saying that is we can use, or we can switch the logarithms into exponential form a lot of time to show that these things are true, right? So the first one we have here, log base a of 1 equals 0, right? Remember, when you have a logarithm, that base of your logarithm, has to be some positive number other than 1, right? So log base a of 1, so what this is saying is no matter what that base is, if the number here is a 1, it's always going to equal 0, right? Log base 7 of 1 equals 0. Log base 0.5 of 1 equals 0, right? Whatever that base is, if this is a 1, it equals 0. So why is that going to be true? Well, if you recall from the other video I did of how to switch a logarithm into exponential form, if I take my base a, raise it to the power on the other side of the equal sign, right? So it's a raised to the 0 power. Well, what does anything raised to the 0 power equal? If you recall the laws of exponents, any base raised to the 0 power equals 1, which is what we have over there, right? So that little circular method to switch from logarithmic form to exponential form, the base raised to this power equals whatever's in here. A to the 0 power equals 1. Well, of course it does, right? Because anything raised to the 0 power always equals 1, right? So if you forget these properties, for some of these properties of logarithms, if you forget what they are, they're pretty easy to figure out. Like if you have log base 7 of 1 and you have to figure out what that's equal to, well, if you remember this property, you just know that if there's a 1 here, it equals 0, and that saves you a little bit of time. But if you forget that this is one of the properties, if you forget that equals 0, you can just say, well, log base 7 of 1, if I have a base of 7, I have to raise it to a power to equals 1. What power does that have to be? Well, it has to be the 0 power, because anything raised to the 0 power equals 1. All right, so again, in the last video that I did, I talked about how I did an example, or a few examples actually, of evaluating logarithms and figuring out what they're equal to. So if you just do that with some of these properties here, you can figure out that this one's going to equal 0 and this one's going to equal 1. It's not a big deal, right? But knowing these properties saves you a little bit of time and saves you the effort of actually going ahead and figuring that out by doing the stuff that I'm writing over here. All right, so log base a of 1 is equal to 0. Whatever that base is, if that's a 1, the logarithm always equals 0. All right, property number 2, log base a of a equals 1. All right, again, think about it in terms of an exponential equation, and you'll see that it obviously has to be true. All right, so what this is saying is I have a base of a, and I have to raise it to some power in order to equal a. Well, what power do I raise something to make it equal itself? Well, I raise it to the first power, of course. Right, so log base a of a, of course, has to equal 1, right? Because the base a raised to some power over here has to equal a. Well, anything to the first power equals itself. A to the first power equals a. Therefore, log base a of a has to equal 1. Right? Remember, with logarithms, you're looking for the exponent. You have a base here, and you have a result. So the base a raised to the power that goes on the other side of the equal sign gives you whatever's in here. So I have a base of a, I'm trying to raise it to a power to make it equal a, that power equals 1. So therefore this whole logarithm equals 1. Right, this one I have a base of a, I have to raise it to a power to make it equal 1. Well, something raised to the 0 power gives me 1, that's why that one equals 0. Right? Again, if you watch the video I did on the definition of a logarithm, we went over some of that in there, and probably what I just said makes a lot more sense if you've already seen that video. All right, the next property here. And again, for the first two, if you forget them, it's not that big of a deal. Like, you don't have to sit there and stare at these for an hour to memorize them. If you forget, you just figure out, well, a to some power equals a. Oh, that's the first power, so it equals 1. You can pretty easily put it back together without actually memorizing it. The last two down here, these are the ones that we use all the time when we're solving equations involving exponentials and logarithms. Again, in that last video that I did, I said that logarithms and exponentials are inverses of each other, right? And inverses cancel each other out. And that's what these two properties here basically are saying. Right? So log base a of a to the x power equals x. Right? So doing this as we did the ones up here in terms of the exponential function, I have my base a, right? I have to raise that to some power, which goes over here, to make it equal what's in here, a to the x power. Well, what power do I have to raise x to make it be a to the x power? Well, that's got to be x, right? A to the x equals a to the x. I want to raise it to anything else. I need to make those two exponents match. The bases are the same, so those exponents also have to be the same. So a raised to the x power equals a to the x power, right? When you switch these into exponential form, they're just obviously true, right? Well, of course, a to the x equals a to the x, right? Of course, a to the first power equals a, right? It can't be anything else. All right, so again, if you understand that, that switching between one form and the other, it helps show you that these properties just naturally have to be true. All right, so that's one way to think about this one is log base a of a to the x. So if the base of this logarithm, and then inside that logarithm we have an exponential expression, and the base of the exponent matches the base of the logarithm, it's like the logarithm and the exponential cancel each other out. And all that's left is that exponent, which is the x. Now, that's what I talked about a minute ago when they're inverse functions, so they cancel each other out. If the base of your logarithm matches the base of your exponent, they just cancel, and whatever that exponent is all that's left behind. That's what it's all equal to. All right, so again, we use that when we're solving exponential equations. If I need to cancel out that base of the exponent, I use that logarithm to cancel out the base. All right, and the last one down here is similar, just kind of going from the opposite direction. Here we had the logarithm of an exponential expression. Here we have an exponential expression, but now the exponent contains a logarithm. So a to the power log base a of x equals x. Again, the base of the exponent, a, matches the base of the logarithm, also a. Therefore, the exponential and the logarithm cancel out, and all that's left is this x that was in that log function. Right? To check that this one's true, we would use, we would put this exponential equation into logarithmic form. All right, so I have a log. The base of my log is the base of my exponent, so it's log base a. The exponent goes on the other side of the equal sign, and the exponent here is log base a of x. So in order to make these two things equal, what goes over here also is x. Right? It's the a raised to this power, right? A to the log base a of x power equals whatever's there. All right, so again, if these ones you took the logarithmic form and switched them to exponential form to see that they're true. This one, since you're starting with an exponential equation, you have to switch it into log form to see that it's true. Right? But when you do that, you see, well, yes, of course, log base a of x equals log base a of x. It's the same thing on both sides of the equation. Obviously, they're equal to each other. All right. So that's thinking about it in terms of switching it to a logarithm. But again, like I said, for this one here, you have an exponent with a base a. You have the logarithm with a base a. That logarithm is in the exponent. The log base a and the exponent base a cancel out, and all that's left is the x. Right? So those are cancellation properties of logarithm and exponential functions, which again, since they're inverses of each other, they're going to cancel each other out as long as those bases match. The bases have to match. Right? If this is 5 raised to the log base 3 of x, and this base is 5 and that base is 3, they don't cancel out. Right? Those a's, those numbers in the bases have to be exactly the same in order for that to work. All right, so those are our 4 properties of logarithms. Now there are some other properties of logarithms that I'll talk about on another video. But right here I'm going to pause this and erase these and just put up a couple examples where we use these properties to simplify expressions. All right, so I put up a few examples up here that correspond to those properties we were just talking about. So the first one, log base 5 of 1, what does that equal? Well, if we remember our properties, anytime you see a 1 here, doesn't matter what that base is, it has to equal 0. Right, now, again, if you forget that, you can kind of figure it out without knowing that property. Right? I can say, well, I have a base of 5, I have to raise that to some power to make it equal 1. Well, if I raise something to the 0 power, it equals 1. So 5 to the 0 power gives me 1, therefore this logarithm equals 0. Right? And again, if you don't understand what I'm talking about with doing it in terms of the exponent, look at that other video that I did about the definition of a logarithmic function and how it's related to exponential form, where we do quite a few examples of switching it between and switching between the forms and evaluating logarithms. All right, log base 5 of 5 equals. All right, again, if we remember our properties, this is pretty simple. Right? If my base here matches my number right here, then this just equals 1. Right? And again, if you think about it in terms of exponential form, the base 5 raised to some power has to equal 5. Well, 5 is 5 to the first power. Right? 5 to the first power equals 5. Therefore, this logarithm equals 1. Pretty simple. All right? Well, pretty simple as long as you understand what a logarithm is, which again I mentioned on the other video that I did. Real important to understand what a logarithm represents. If you understand that, then all this other stuff we're doing is just kind of follows directly from that understanding of logarithms. Log base 5 of 5 to the 8th power. All right, so I have a base of 5. I need to raise it to some power and have it equal 5 to the 8th power. Well, if I take 5 raised to the 8th power, that equals 5 to the 8th power. Right? Or another way to think about it is if the base of my logarithm matches the base of my exponent, they cancel out. And all that's left is that 8 that's up in the exponent. All right, so this equals 8. Now, one thing I do want to point out, this one up here, example B, actually is the same property as example C. Right? Think of this, the log base 5 of 5. This is a 5 to the first power. Right? So the log base 5 and the 5 of the base of the exponent cancel out, and all that's left is that exponent, which is a 1. Right? So really, the second property that I had up here before is really just a special case of that third property when that exponent is equal to a 1. Right? So really, it's the same property. All right, so log base 5 of 5 to the 8th equals 8. The base of 5, the base of the exponent 5, cancel out. All right, same deal going to happen here. 5 to the power log base 5 of 12. Well, here I have an exponential equation, but my exponent contains a logarithm. And the base of the logarithm, right, the 5, equals the base of my exponent, also 5. If those are the same number, the exponent and the logarithm cancel out, and all I have left is the 12. Right, so 4 examples there, following directly from those 4 properties of logarithms that we had up here a few minutes ago. Again, they're shortcuts, right? The first two, if you forget those properties, like I said, it's not a big deal. If you understand what a logarithm represents and you understand how to evaluate a logarithm, like we did several examples of on the other video that I did, you can figure these out pretty easily just by doing like that, right? These two here are a little bit more important to remember, the cancellation properties for logarithms and exponents. Because we do use those a lot when we get into solving exponential and logarithmic equations, which I'll be making videos about those pretty soon. So yes, make sure you understand when these cancel out, so that you can do that to simplify those types of expressions, right? And if some of the stuff I talked about on this video did not make sense, you might want to go back and watch the first video that I did about the definition of a logarithm and how it relates to exponential functions. And really getting that understanding makes a lot of this other stuff we do with logarithms make so much more sense, right? So make sure you understand that and you're able to do that stuff before you go too much further with logarithms.